Good morning. Today we will discuss Arene and aromaticity in B.sc first year chemistry. The topic is electrophilic substitution reactions. Electrophilic substitution reactions are the most important reactions of benzene. Benzene is a nucleophile, though its nucleophilic character is diminished by delocalization of pi electrons. Even then, its pi electrons are easily available to an electrophile. Thus, the electrophilic substitution reactions are common to benzene ring, just as the typical reactions of alkenes are electrophilic addition reactions. Electrophilic substitution reactions are characteristics of benzene ring and also of many other aromatic systems. Another point is general patterns of mechanism. The mechanism of electrophilic substitution reaction is a two-step process. First step involves the addition of the electrophile to the benzene nucleus, forming a resonance-stabilized carbocation intermediate or VLAN intermediate. This is a slow and rate-determining step. In the second step, carbocation loses a proton forming substitution benzene derivative. This is the general pattern of mechanism. On the basis of following evidences, it is now well established that it is two-step mechanism that operates in electrophilic substitution reactions. Another point is isolation of intermediates. The intermediates of aromatic electrophilic substitution have not only been detected but have also been isolated and characterized in several cases. For instance, the isolation of an intermediate in the reaction of benzo trifluoride with BF3 and nitrile fluoride at minus 80 degrees centigrade. It is a yellow crystalline complex that decomposes on warming to minus 50 degree, giving metanitrobenzo trifluoride BF3 and HF. Similarly, in the reaction of acetylene with ethyl fluoride and BF3 at 80 degree, an intermediate has been isolated as depicted below. In this reaction, acetylene reacts with ethylene fluoride, gives an intermediate. And another point is isotopic effect. The electronic structure of isotopes of an element are exactly similar, but they behave differently because of the difference in mass. It is expected that isotopes cause the difference in the rate of reaction due to difference in their mass. The difference in the rate due to a difference in the isotope present in the reaction system is called an isotope effect. The rates of nitration of deuterio and tritiobenzene, for example, are the same as the rate of benzene. Thus, it is reasonable to conclude that proton elimination is not the rate determining step of the reaction, and therefore the one-step mechanism is inconsistent with experimental observations. Electrophilic substitution versus electrophilic addition. The preference of aromatic compound to undergo substitution rather than addition is associated with aromaticity, that is, retaining of magic aromatic sextate 4 and plus 2 pi electrons. The addition products will no longer retain this special feature and will therefore be far less stable than the starting aromatic compound. Completely delocalized pi orbitals are recovered by the removal of a proton from the carbocation, thus retaining their aromatic character. In this reaction, this type reacts and forms substitution and gives substitution product. This benzene on nucleophilic addition gives addition product, that is alicyclic compound. Aromaticity lost. Another point is a role of sigma and pi complexes in aromatic electrophilic substitution. Both sigma and pi complexes are intermediate in aromatic electrophilic substitution reactions. The sigma complex involves the actual bonding of the electrophile to the substrate atom, and the formation of sigma complex preceded the initial formation of pi complex. On the other hand, the pi complex does not involve actual bonding, but the electrophile is held by a pi electron cloud of the aromatic ring. The initial step of electrophilic substitution involves the approach of the electrophile on the pi electron cloud of the aromatic ring and is result in the formation of a pi complex. Now the pi complex changes into sigma complex by taking a pair of electrons from the ring and forms a sigma bond with one of the ring carbon atom with positive charge delocalizing on remaining 5 carbon atoms. The resonance stabilized carbocation is referred as sigma complex. This sigma complex eliminates a proton with before departing from the aromatic ring again forms a pi complex. Sequence of various steps involved in the mechanism of electrophilic aromatic substitution can be illustrated. So this is all about in electrophilic substitution reactions in Arenes and aromaticity.